హాయ్ ఫ్రెండ్స్, ఈరోజు ఇంకొన్ని ప్రాబ్లమ్స్ చూద్దాం. At a particular stage of a reaction steam turbine, the mean blade speed is 60 meter per second. Steam is at a pressure of 3 bar with a temperature of 200 degrees Celsius. If the fixed and moving blade at this stage have inlet angle 30 degrees and exit angle 20 degrees. Determine first one, blade height at this stage. If the blade height is 1 by 10 of the mean blade ring diameter and the steam flow is 10 kg per seconds. Point B, power developed by a pair of fixed and moving blade rings at this stage. And C, the heat drop required by the pair. The steam expand with a efficiency of 85%. Okay, so now this is the problem. Now we are going to solve this one. Solution, first one is given. I'm going to write given. So first one is given here, blade velocity VB is equal to 60 meter per seconds, pressure 3 bar, at the same time temperature is given, that is equal to 100 degrees Celsius, and now theta is equal to beta is equal to 30 degrees, pi is equal to alpha is equal to 20 degrees. Okay, so now we are going to solve first one, is blade height, and now we are going to find blade height. Before we draw, here is combined velocity diagram. So now I am going to draw combined velocity diagram in here. This is VB, we know very well. Now the two angles is given, 30 degrees and 20 degrees. This is for inlet, this is for outlet, we know very well. So now I draw here 20 degrees. So here is the point is called C. Now I take this is 30 degrees, VR. This is inlet blade, and now I'm going to draw here outlet. Okay, this is outlet blade. So now here is coming 20 degrees and 30 degrees. Then I put it here D. Now from inlet blade at the same time and exit blade, I draw two vertical lines, two horizontal lines. This is intersecting point is called E, and then this is called F. Okay, here is VR, here is V1, VR1, VF1. Then you take this is VF. This is called change in real velocity, VW plus VW1. Okay, we know very well that how to draw the combined velocity diagram. So now I am going to solve in here blade height. First one is going to find blade height. Let D is equal to mean diameter of blade ring, then H is equal to blade height, that is coming from here d by 10, and now we are going to solve here. M is equal to mass of steam flow, that is equal to 10 kg per seconds. Okay, why? Because this data is given in blade height. Okay, 10 kg per seconds also given. Now here I am going to solve this change in the velocity of reel. Okay, so before going that, I am taking this diagram, combined velocity diagram. Okay, uh, to going to solve with the sine rule. Okay, with the sine rule I am going to solve change in reel velocity. Okay, now we will see how to solve this thing. In this, here in sine rule, v divided by sine 150, that is equal to vr divided by sine 20 degrees, that is divided by 60 divided by sine 10 degrees. Okay, why? Because this is we are applying sine rule in here. We know already sine rule. Previous I explained this sine rule, about sine rule, but anyhow I draw here 60 v vr. I take this triangle like a b c. Okay, now this triangle. Okay, I can take this triangle. Now here how much angle it will come, and now this is given 20 degrees. Okay, I put it as this 20 degrees now here, and then here how much angle it will come. So we take this velocity, it will come here. Okay, this is the main important thing here, is coming from this is angle here, we know 30 degrees. Look at this, here is 30 degrees. Now this is totally 180. This is 180. 180 minus 30 is coming from here 150 degrees. Okay, and now then here you can see this thing. Okay, I taken this like this. Now here it will come 20 degrees, right? Okay, this is 20 degrees it will come, and then now here see this, here it will come 150 degrees. Then okay, see this, here to here 150, and then similarly here to here is 150. So total it will come, total is 180 degrees, 180 degrees. Okay, so this is 180 degrees. Now how much it here, 150 plus 20 is called 170 degrees only. So the in between gap is coming from 10 degrees. Okay, and then here 60, what is the sine rule? Here I am going to apply sine rule. 60 opposite in between angle. Okay, in between angle, this is 60 divided by sine 10, and then v you can take this opposite. Okay, opposite in between angle. Okay, that's called, come here 150 degrees. Then go for vr. Look at this, vr is also going to like this opposite. Okay, angle is coming from 20 degrees, I taken like this. Okay, so now we are going to solve the unknowns here. So first vr is equal to 60 divided by sine 10 degrees into sine 20 degrees. So then solve this, is we'll get the answer in here, 2 meter per seconds. Okay, similarly we are going to solve vf is equal to, now this the vf we can take this triangle, but here is unknown is there. Now we know very well about v. Okay, then you can solve this triangle. You can take uh, b c e. Okay, this triangle b c e triangle. Then here we get v r sine 30 degrees. Okay, you can take this vf, here you taken vr. Why? Because we know vr, we don't know v. So okay, now solve this. We will get here vr is equal to 118.2 sine 30 degrees. This is coming from 159.5 meter, 59.1 meter per second. This triangle is taken here ACE. ACE. Okay. Now EA, that is equal to VR cos 30 degrees. Simply here we find out sine 30 degrees, and then that is coming from here around 102.4 meter per seconds. Okay, now we find out here VW plus VW1, that is called EA plus AB plus BF. So here I put it EA is equal to BF also. Why? Because same angles. Okay. So now here I substitute the values 1.02.4 plus 60 plus 102.4. Calculate this, will get to 64.8 meter per seconds. Okay. Now we find out this real velocities. Okay, and now we are going to, now vf1 is, you can take here vf1 is taken here df. Okay, that is equal to 60 meter per seconds, right? Okay, so then here you can solve this thing vf also. Okay, approximately here it will come 59.1. vf was equal to vf1 also. Vf is equal to vf1. So then I take approximately 60 degrees, 60 meter per seconds. Okay, here is 59 point something. And now I am going to solve blade height. So before going that, from steam tables I want collect unknown data from steam tables. Here is pressure is there. What is the pressure is given? Pressure is 3 bar, and temperature is given 200 degrees Celsius. Okay, we know that the specific volume of steam V super is equal to, you can take G or VG also, you can write down, no problem. Okay, that's the meter cube per seconds. And then we go to solve here. We know that, I write down an equation, that mass of steam flow. So mass of steam flow m. Okay, that's the thing here. M is equal to pi into d plus h into h vf1 divided by v g or v per saturated transport. So okay, now here I substitute 10 by 10h plus h h into v, sorry, vf is 60 already we find, and now here 0.7164. Then calculate this, we'll get approximately it h square. So now h is equal to 0.059 meter, then that is called 59, say 60 mm. Okay, Now we going to blade height is over. Now then point B is power developed. Now we are going to solve power developed. We know that power developed by a pair of fixed and moving blade rings P is equal to M into VW plus VW1 into VB. Then substitute this all values in here. We'll get power or 159 kilowatt. And then point C is their heat drop. Okay, heat drop required since the steam expands with an efficiency of 85 percentage. Therefore, heat drop required by the pair is equal to 159 divided by 0.85. So 187 by 187 kilojoules per second is the heat drop. Okay, this is the procedure to solve this problem. And now we are going to see another one here. Problem number 6. At a certain pair in a reaction turbine, the steam leaves the fixed blade at a pressure of 3 bar with a dryness fraction of 0.98 and a velocity of 130 meter per seconds. The blades are 20 mm and the discharge angle for both the rings is 20 degrees. The ratio of axial velocity of flow to the blade velocity is 0.7 at inlet and 0.76 at exit from the moving blade. If the turbine uses 4 kg of steam per second with the 5% tip leakage, find the mean blade diameter and the power developed in the ring. Good. So this is the problem. Now we are going to see how to solve this one. Now I am going to write down here solution. First I am going to take given data. B is equal to and P is equal to 3 bar, X is equal to 0.98, V is equal to 130 meter per second, H is equal to 20 mm, that is called 0.02 meters, and then here alpha is equal to pi, that is equal to 20 degrees is given. Vf is equal to 0.7 VB, Vf1 is equal to 0.76 VB, M1 is equal to 4 kg per second is the given data. Now here is given leakage 5%. 5% of tip leakage is given. So then here M is equal to 4 minus 4 into 1.05. 3.8 is kg per seconds. Okay. Without leakage means you can take directly 3.4 kg per second, but here is given leakage, then you can calculate like this. And now we're going to see here blade diameter. Now we are going to solve blade diameter. Okay, that is called mean blade diameter, dm. Okay, then here from the combined velocity of triangle we find the velocity of flow at the inlet is equal to, in here before going that so we are going to draw the velocity diagram from there, but here I don't know how much, so we can take this is VB, I don't know, so A and B, then this is coming from here is 20 degrees, then this is also 20 degrees, but outlet angle we don't know. So see this thing, Okay, then this is called vf1. Sorry, here is vf only. So here I can take this thing here, vf is equal to, from this diagram, vf is equal to v sine 20 degrees, right? Yes. Now here v is equal to 130 into 0.342, that is equal to 63.5 meter per seconds. Okay, so now here how can take the value of here vf is equal to 44.46. Okay, and then now we can, so vf value we find out here. Okay, now v is given, velocity is given. I take here, look at this, velocity is given 130 meter per seconds. Okay, and now vf is, we know, then vb is equal to vf divided by zero point 0.7. This is also I am taken from given data. So what happened here, sorry, this is 44.46. Okay, that divided by point some, the confusion. Okay, right. Now this is meter per seconds, vb, then vb is equal to 63.5 meter per seconds is find out. V is equal to 130 meter per seconds is given. Okay, vf we find out, and then now we go for, therefore, velocity of flow at exist. So vf1 is equal to 0.76 vb is given, then 0.76 into 63.5, so then 48.3 meter per seconds. So we need here vg value, specific volume. So then we go for steam tables. Now from steam tables, corresponding pressure at 3 bar, then the specific volume vg is equal to 0.6055 meter cube per kg. Then we know the mass m is equal to pi d, mean diameter, into h vf1 divided by x into vg. Now substitute these values in here. dm we don't know, 0.02, 48.3 divided by 0.98 into 0.6055. Okay, then m is equal to, you take m is equal to 3.8 kg per seconds. Can substitute these values, we will get here dm is equal to 0.745 meters, that is coming to around 745 mm. This is the answer. And then now here by measurement we find the change in the velocity of rel is equal to vw plus vw1 is equal to ef, then that is called 190 meter per seconds. Okay, so you know that power developed P is equal to m into vw plus vw1 into vb, then m is equal to 3.8, 190 into 63.5. So now calculate this, 45850 kilowatts or 45.85 kilowatts. Okay, sorry, this is watts and this is kilowatts. Okay, so this is the problems to solve the reaction turbine, and next class we are going to see steam condensers. Okay, thank you.